Richard James will present Transposition Tutorial 2. And as a matter of fact, it's a mere continuation from the one that we have just completed. This problem is very similar to one that we have solved before. And if there is only one thing that we do not do in mathematics is reinvent the wheel. Especially since the advent of computer programs, if there is one thing that mathematicians are adept at, is the ability to adapt a solution of a previous problem to suit another one that is quite similar. This is particularly true for mathematicians like myself, who are computer programmers. This solution may turn out to be one step shorter than the similar one in tutorial 1. This is because there is no other fraction on the same side as the fraction that contains the proposed subject. So we had a previous problem with 3 fractions, and on the previous occasion one of the other fraction was accompanying the proposed subject on the right hand side. We do not have that situation right here. As a matter of fact, this other fraction is exactly where we want it, on the other side, and that will cause the solution to be one step shorter than the one that we are saying that this one is analogous to. When we are solving by analogy, we make use of the ones that are similar, and when we have something that is somewhat different, then we make the necessary adjustment. Solving by analogy does not mean that the problem will be the same in all respects, but we will use, or we may use, aspects of the problems that are similar to help us in our solution. Since the fraction that contains the proposed subject is alone on the right hand side, we will go straight ahead and write the left hand side as a single fraction, as we have done time and time again. So we will not bother to go through the details and go back to the first principles and all of that. We just go straight ahead and write the 2 fractions that are on the left hand side as one fraction in the same way that we are accustomed to. And we usually say that if the denominators of fractions are exclusive, they do not have any common factor, then there is a very quick way of writing down the sum of those fractions. The new denominator will be the product of the 2 denominators, and then we have in the numerator the product of those 2, and also the product of those 2. And no doubt it is equal to 70, as we have right there. And be reminded that this red bar is here between these 2 expressions to indicate that we are taking a look at the intermediate step that will transfer this expression, or transform this expression, into this one. The left hand side was written as a single fraction because the proposed subject is in the denominator on the right hand side. It will be better in the numerator. We therefore reciprocate both fractions, but we cannot do that unless we have 2 fractions, one on either side. The reason why we wrote the left hand side as a single fraction is because we have the denominator here being the proposed subject. if we have the proposed subject in the denominator, the easiest way to get that in the numerator is to reciprocate that fraction. But we cannot do that unless what we have on the other side is a single fraction. Therefore, we write the other side as a single fraction. Then we may proceed to reciprocate both of them. In all cases, when solving by analogy, we take similar steps under similar circumstances. Let us go straight ahead and eliminate the 7 from the denominator of the fraction that contains the proposed subject in exactly the same way that we have done for the previous problem. And how did we eliminate that denominator? How do we generally eliminate a denominator? A denominator is something that we divide by. Therefore, in order to eliminate that denominator, we will multiply by that same number that is in the denominator. Well, on this occasion, it is a number. Maybe at some other time, it will be an expression. And I am sure that we will see that before the end of this tutorial. So we will eliminate that single 7 that we are dividing by right there by multiplying by 7. And we cannot do that on one side. It is an equation, so we need to do that on both sides. And what do we notice? That right here, the 7s cancel each other, and all that is left on the right hand side is t. Therefore, all that we need to do now is reverse the equation, writing the proposed subject on the left hand side. So let us finally reverse the equation in order to cause the proposed subject to become the subject. So that is all that is left in this step. To move from here to here is a matter of turning the expression around. And that is all there is to it. What we have there is somewhat of a standard problem, and we will do a little discussion on it before solving it, because we imagine that when we come across another one like this, then we will solve it by analogy. We will pay special attention to the detail of the solution of this problem because it is somewhat of a standard problem. We will first discuss each step in its solution, then we will actually solve the problem. Number 9 is analogous to it. Notice that what we have right here, we have 2 occurrences of the proposed subject. One in the numerator and the other in the denominator of the fraction. Eliminating the denominator will result in the 2 occurrences being on either side of the equation, like we have right here. So when we eliminate this denominator, we will have 2 occurrences of the proposed subject on either side of the equation. We will take the necessary steps to have the 2 occurrences of the proposed subject on the same side of the equation. So now that we have 2 occurrences on either side, we will take the necessary step to have them on the same side, right there. And what do we do after having them on the same side? We have done that already. Now we have 2 occurrences of the proposed subject on the same side. In order to complete the transposition process, we need only 1 occurrence. This may be achieved by factorization, using the proposed subject as the common factor. So we need only one occurrence. We have two. Factorization will help us to realize that single occurrence that we need in order to make y the subject of the formula. So we will factorize, and after factorization we will divide by what we call the large factor. The proposed subject and the other factor are in a multiplication relationship. We will therefore divide by that quote-unquote large factor in the end. So we are making y the subject. We have this, what we call the large factor, x minus 1. What do? We divide, because they are in a multiplication relationship. We will eliminate x minus 1 by division. These identical steps may be taken whenever we have two occurrences of the proposed subject in the numerator and denominator of the same fraction. But as usual, we may have adjustments to make with signs and other terms that surround our central theme. And our central theme is to make whatever is given to us the subject of the formula. And I am saying that we may take identical steps in solving a problem in which we have the proposed subject occurring in the numerator and the denominator of the same fraction. In that first step, we will eliminate the denominator. A denominator is actually a divisor. We eliminate it by multiplication. Do that, which is that multiplication on both sides. So we need to eliminate this denominator, which is a matter of flattening the equation. What do? Eliminate a denominator by multiplication, but we have to do the same on the other side. So multiply both sides by y minus 3. What happens? What we imagine will happen on the right hand side, the right hand side will see y minus 3 being eliminated. So on the right hand side, the denominator is eliminated and the left hand side is multiplied by y minus 3. With the proposed subject enclosed by those brackets, we will expand the brackets. So by multiplying, as a matter of fact, I am doing it on this occasion with the intention that I will not have to do it again to make it plain. When multiplying by this denominator, the denominator is comprised of two terms, y minus 3. So multiplying on the left hand side, we will have to take those two terms to multiply this x. Therefore, the best way to demonstrate that right here is to enclose the y and the negative 3 with brackets, so that it is very plain that we need to multiply by x. So x times y and then x times negative 3. Like that. And also like that. And what do we know? Everything is eliminated from that right hand side, so we have y minus 2 right there. On other occasions, which is the ones to come, we will not include brackets, then expand them. We already know that we will have to multiply the terms. We will just do that. So we will not take, in subsequent situations, this denominator and write it in brackets on the other side. Then we'll have to do another step of expanding the brackets. We understand already that we will have to multiply any number of terms that we have here by the term that we have there. And instead of putting the brackets and then go ahead and expand the brackets, we will just do that in one single step, which is multiply the terms. And we will see that when we get there. The following two steps may be taken in one, but for the visual effect of this computer-generated solution, we will do them one after the other. As we have them right here, we have taken them in one, but on this computer-generated solution, we will do them one after the other. We will take the necessary steps to get the terms that contain the proposed subject together on one side. And we will do that by first subtracting y from both sides. So what we intend to do from here on, which is to get to this step, is use those terms that contain the proposed subject and let them be on one side and the others on the other side. And we will take a look at those. Well, here we have it as a single step, but we'll take a look at how we may do that in two steps, just to ensure that the details of doing that is explained. So, need to eliminate this y here so that we can have it occurring here. Subtract y from the right hand side, and subtract y from the left hand side also. On the right hand side, y is eliminated and y is subtracted from the left hand side. See, we have them eliminated on that right hand side and we are subtracting y on the left hand side. So there we have on our left hand side xy minus 3x minus y. So we have the y's together on the left hand side, but everything else should go to the other side. Therefore we need to eliminate this negative 3x from that left hand side. And negative 3x, subtract 3x, the opposite of that, add 3x, and we'll add 3x to the other side. And what do we know? Negative 3x is eliminated from the left hand side, and 3x is added to the right hand side, because we are eliminating that negative 3x by adding 3x. So 3x will be added to the right hand side. The positive sign that precedes the 3x on the right hand side is not necessary, and we will not see that occurring in the next step. So we have a positive 3 right here. We will not see it here because it is not completely necessary. And what do we do? Apart from go to the next slide, we now have the two occurrences of the proposed subject on the left hand side. We need only one occurrence, and that we will achieve by factorization. Do that by taking y as the common factor and divide each term by the common factor. That is how we factorize. We always take out the highest common factor and we divide each term by the highest common factor. So there we have the common factor is taken out, and we have the term here divided by the common factor divided by the common factor. So what do we have? In the first term, the y's will cancel, leaving x, and y into y, any number divided by itself, is equal to 1. So in the second term, y divided by y is equal to 1. Therefore, we will have x minus 1. So these will be eliminated. These, all that is left, x minus 1 to be multiplied by y, and the right hand side remains the same. What do we do next? We will make use of the fact that y is being multiplied by all of x minus 1. That is what this means, and there is no doubt and there is no need to explain any detail of that. We do not have an operator separating them. The assumed or the default operation is multiplication. Therefore, we will assume, as a matter of fact, it really is being multiplied by x minus 1. So to eliminate, we need to divide by x minus 1. So let us go straight ahead and divide both sides by x minus 1. There we have it. And what will happen? X minus 1 will be eliminated from the left hand side, and on the right hand side we have 3x minus 2 over x minus 1, and that is our answer. Let us have some fun. In this problem, we are given two formulae. Well, as it is said in a Jamaican proverb, bullfrog say, what is joke to you, a debt to me. But I'm saying, and my students always say that when I'm saying that we should have some fun or I enjoy a problem, it is because it is very difficult. Well, I do not think it is difficult. You will see that it is not difficult. And as a matter of fact, I enjoy taking a go at problems that look difficult, because the ones that have appearances of difficulty are usually ones that have a loop of simplicity, and that one can greatly reduce the effort that we will take in solving the problem. As a matter of fact, I always say 2 takes longer than 5. It is better to take 5 extra seconds looking at a problem or analyzing a problem than 2 extra minutes solving it. Let us take a look at this one. As a matter of fact, as I said before, let us have some fun. In this problem, we are given 2 formulae. V is the subject of one and C is the subject of the other. In the end, we are expected to express V in terms of C. That is the requirement. Express V in terms of C and R. We may therefore use one of the formulae to write pi in terms of the others. Then substitute that expression for pi into the other equation. Now, since we are transposing formulae, we are given these formulae, then one might imagine that the best way out is to transpose. Well, I opt to differ. One might want to take, this is a way out, take pi here and make pi the subject of the formula. Take pi over here and write pi as the subject of the formula. Then equate the two right hand sides, and after you have done that, then you may go straight ahead and make V the subject of the formula, and that is pretty much an excellent solution. Or you may use this equation and transpose it, make pi the subject, and then substitute what you get for pi into this equation. That's another way. But the easiest way of solving this problem, we will take a look in a short while and we will see that. After so doing, we may have to make other adjustments. That is, after taking pi as the subject and substituting the expression into the other one, after doing that, we may have to make other adjustments in order to satisfy the requirements of the statement of the problem. That is, making V the subject, or writing it in terms of C and R. However, if we take a second look at the expression, we may find a loop of simplicity that we may use to make the solution simpler and quicker. What is that? First, let us write R squared as R multiplied by R. This is with the intention to cause the other formula to resemble as much as possible 1/3 pi R squared. If we divide both sides of the second formula by 6, we will get a very close resemblance between the two formulae. So let us do that. 1, we write R squared as R times R, or RR. Minor adjustment. In the other one, what do? Divide each side by 6. So by so doing, we will have a reduction by 2 right here. So reduce by a common factor of 2. Reduce the right hand side of this equation. So we have that 2. 2 into 6 is 3, and 2 into 2 is 1. So we have 1/3 pi R. So we have C over 6 is equal to 1/3 pi R. Look at this now. 1/3 pi R. And look at this, 1/3 pi R. So all we need to do is take out this 1/3 pi R from here and put C over 6 in its stead and see what happens. Since C over 6 is 1/3 pi R, in the other formula where we see 1/3 pi R, we replace it with C over 6. As easy as that. So replace 1/3 pi R by C over 6. That's all. Finish. V is equal to CR over 6. There's nothing to it. Well, it is as easy as that. It only takes a bit more eye with added imagination. So take a second look at it. Open your mind and open your eyes. This problem looks quite similar to the ones that we have solved before. That contains the proposed subject in the denominator of one of the fractions. Like what we have right here. The proposed subject is y in the denominator of the fraction. The fact is that one of the terms is not a fraction, and although we may take the same steps as in the others, it does not make much sense making a non-fractional term into one. It is better that we eliminate the fractions. So do not convert this into a fraction and then manipulate fractions. Instead, we will eliminate all of the fractions, and that we will do by multiply by the common denominator, which is an expression that each denominator can divide into without leaving a remainder, and the common denominator in that particular case is 3y. Well, in the end it might boil down to a matter of preference, because some candidates may not consider the two methods to be much different in complexity. So it might boil down to a matter of preference. I will want to reciprocate, but the other one will want the denominator to eliminate. In order to eliminate the denominator, we need to multiply the entire equation by a term that both 3 and y can divide into without leaving a remainder. That term is 3y. So there we have it, the entire equation, and let us go straight ahead and multiply by 3y. In one fraction, the denominator of 3 will be cancelled, and in the other, y will be cancelled. Let's see. Multiply by 3y. Well, we may just go straight ahead and multiply by 3y. So let us see term by term, but we'll take a look at it under the microscope. Let us see term by term how the fractions are taken care of. We need also to demonstrate that the non-fractional term is not to be left out of the multiplication. So we will multiply 2x over 3 by 3y. What will happen? The 3's will cancel. 2x times y is 2xy. Of course, divide by 1. Anything divided by 1 is equal to that same number or expression, as in this particular case. Then we will take the other fraction, 4 over y. We will multiply that by 3y. The y's will cancel. 4 3 is 12. Divide by 1. 12 divided by 1 is equal to 12. And in the other case, we have what? 1 multiplied by 3y. We have to multiply every single term by the common denominator. Any number or expression multiplied by 1 is equal to itself. And we'll do a little bit of computer, because when something looks strange on the television, we call it television, or we call it camera trick. Now here we have a little computer trick, putting those together very nicely. So there we have the flattened equation. Quite recently, we took steps to accumulate the terms that contain the proposed subject on one side of the equation. We will do the same right here again. On this occasion, we will assemble them on the right hand side in order to reduce the number of negative signs. And we will take a look at what it means to reduce the number of negative signs in a short while. So what do? We eliminate the 2x from the left hand side. So we will eliminate the 2xy from this left hand side by subtracting 2xy, and we will do that on the same side, on the other side. And what do we know that will follow? On the left hand side, 2xy is eliminated and 2xy is subtracted from the right hand side. So in our next step, all we have is 12 on that left hand side, and on the right hand side we will have 3y minus 2x. And what do we do now? On the left hand side, 2xy is eliminated and 2xy is subtracted from the right hand side. What will we do? As usual, when we have two occurrences of the proposed subject, we will factorize, making it into one occurrence. And how do we factorize? We take the common factor out, and the common factor is y. And what do we do after that? Divide each term by the common factor of y. There we go. And what do we know? Y's are gone there to give 3 alone. Y's are gone there, we have 2x. So we have 3 minus 2x remains. Like that. 3 minus 2x. And we will go to the next slide, where we will say we need to complete that solution by dividing by this common factor. We are solving by analogy, and we do not have to labor on each step. Let us go straight ahead and divide both sides by 3 minus 2x. So there we have 12 is equal to y times all of 3 minus 2x, which is the quote-unquote large factor. It is being multiplied by 3 minus 2x, and we need to make 3 minus 2x the subject of the formula. So what do? If it is being multiplied, we divide, and we do the same to the other side. And what will happen? The term will be eliminated, and on the left hand side we have 12 divided by 3 minus 2x. So on the right hand side 3 minus 2x is eliminated, and on the left hand side we have whatever we have there, 12 divided by 3 minus 2x. And as usual, we only have a single step to complete our solution, and that is we will reverse the equation in order to cause the proposed subject to finally become the subject. On the next slide, we will take a look at what we meant earlier on when we said that we accumulate the proposed subject on the right hand side in order to reduce the number of negative signs. We said earlier on, as a matter of fact, given this particular case where we have to make y the subject of the formula, it will be good, we imagine, if we can get the proposed subject to very quickly be on the left hand side. So that is always something that we have in our minds, to get the proposed subject to be on the left hand side. But we did not do that. Instead, we accumulated the terms that contain the proposed subject on the right hand side, and then we reverse the formula in the end. And we will take a look at why I did that, although the other one is not wrong. So on this occasion we will take a look at the steps that are necessary to accumulate the terms that have the proposed subject on the left hand side. We will begin by eliminating 3y from the right hand side. So this time, on this occasion, we are accumulating them on the left hand side in order to explain why we actually accumulated them on the right hand side. So let's go. Kinda sound like a paradox, or even what we'll call an irony, that we are accumulating the terms on the left hand side in order to make it plain the reasons why we actually accumulated them on the right hand side at first. So we will eliminate that 3y from the right hand side by subtracting 3y. We do that to the left hand side also. On the right hand side, 3y is eliminated and 3y is subtracted from the left hand side. It is inappropriate and contrary to good mathematical principles to leave one side of an equation blank. Besides, 3y minus 3y is equal to 0. There we have it. And what do we do next? We need to, now that we have the terms that contain the proposed subject on the left hand side together, now we will cause the one term that does not have the proposed subject to be on the other side. And what do? We eliminate this 12 from the left hand side by subtracting 12. So there we have 12 is eliminated from that side, left hand side, and on the right hand side we have a negative 12. 0 minus 12 is equal to negative 12. So 2xy goes there, negative 3y goes there, and a negative 12 right there. From here on, we may do the same, namely factorize by using the proposed subject as the common factor, then divide by the large factor. The answer will be just as good as the other one. As a matter of fact, a candidate should get the same full marks irrespective of the approach. So, well, we may not do that immediately. However, there are quite a few things that are not so attractive to mathematicians, and that negative 12 that we have right here in the numerator of the answer is one of them. Now this negative 12, although we do not have that in the numerator of the fraction as yet, which would have been appropriate generally, but we will look at why it will or should not, or some do not consider it to be appropriate in the particular case that we have right here. So there are quite a few things that are not so attractive to mathematicians, and the negative 12 that we have here, which will eventually be in the numerator of a fraction, is one of them. So this negative 12 in the numerator of the answer is one of them, especially when the answer may have been written differently. That is why the early step was taken to ensure that the negative numerator was avoided. There we have a look at what the answer would have been under the circumstance. Let's go again from over here. Over here, we will take the common factor of y, and then we will divide by 2x minus 3. There we have it. Y is equal to negative 12 over 2x minus 3. For paper 2 solution, there is nothing to worry about. However, if the problem were a multiple choice, there is a great chance that you would never see an answer like that as one of the options. That does not make it wrong. It is only of a different form. Other things that mathematicians do not like are negative denominators. A radical denominator, that is one that has the root sign. So they do not like to have the root sign in the denominator. Mathematicians do not like that. And an expression that begins with a negative term if it can be avoided. Mathematicians do not like to begin an expression with a negative term if it can be avoided. The form of the answer may be converted to the previous one by multiplying each of the term in both numerator and denominator by negative 1. So this is the one that we have right here, and we can convert that by multiplying both numerator and denominator by negative 1. See, negative 12, multiply that by negative 1, positive 12. But if we multiply 2x by negative 1, we will have a negative 2x. So what we do is take the negative 3 first, multiplied by negative 1, and that turns out to be a positive 3, goes to the front, and we'll take the negative 1 and write it after, like that, and it is exactly what we have right here. Negative 3 was multiplied first in order to begin the denominator with a positive term, especially that it is possible. In previous tutorials, we discussed that multiplying both denominator and numerator of a fraction by the same number does not change its value. Here we are multiplying both of them by negative 1. So we are multiplying both numerator and denominator by negative 1, which is what we have done right here. And we know that multiplying both numerator and denominator of the same fraction by the same number does not change its value. We could have achieved the same thing by changing all of the signs in both numerator and the denominator. So we could have achieved that by just saying, alright, change this sign to a positive, change this one to a negative, change this one to a positive, and that's all there is to it. So that is the interface of it, that all of the signs are changed. But we are taking a look at the program that is written behind the interface, which is telling us that multiplying the numerator and the denominator by the same number does not change the value of the fraction, and we are doing that by multiplying by -1, both numerator and denominator, as a matter of fact. Number 9, as we said before, is analogous to number 6, that we have the proposed subject in the numerator and the denominator of the same fraction. What do? We just go straight ahead and multiply by this denominator. That's what we did, and that's what we will do again. Multiply, eliminate the denominator. This problem is analogous to number 6. We will not prove that we know any more mathematics by fighting it. Let us go straight ahead and eliminate the denominator, and do not forget what I said. I said that we will not use brackets on that left hand side anymore, because it is already understood that we will multiply this b by a and we multiply this b by 3. So we will have b times a is ab, and b times 3 is 3b. So we'll have ab plus 3b, ab plus 3b, and we are multiplying, eliminating the denominator on the right hand side. So on the right hand side, the denominator is eliminated, and the left hand side is multiplied by a plus 3. The brackets were not included because we would still have to expand them. Instead, we went ahead and multiply each term by b right off the bat, as it is said. So all we have there, that on the next slide we will accumulate the terms that have the proposed subject on the left hand side. The proposed subject is a. We need to accumulate the a's on the left hand side, and we will do the same. The terms that contain the proposed subject will be accumulated on the left hand side. First, subtract 3a from both sides, because a needs to be transferred or transposed to the left hand side. We will eliminate it, 3a, from the right hand side by subtracting 3a. See, on the right hand side, 3a is eliminated and 3a is subtracted from the left hand side. And what do? Now that we have the a's accumulated on the left hand side, we may go straight ahead and factorize. Wrong. We need to eliminate that term that does not contain the proposed subject from that left hand side, and that we will do by minus 3b. So let us subtract 3b. Usually when transposing, we accumulate the terms that contain the proposed subject on one side and simultaneously dispatch the others to the other side. So let us eliminate 3b from the left hand side. There we have it. 3b is eliminated from that left hand side. 3b is subtracted from the right hand side. So we will have ab minus 3a as we have here, and 2 minus 3b. Nice. What do we do next that we have two occurrences? What do we always do when we have two occurrences? We have two occurrences of the proposed subject, but there can only be one subject. Let us take the proposed subject as the common factor in factorizing the left hand side. Take the common factor and divide each term by the common factor, and the common factor that we are using is a, which is the proposed subject. And what do we know? Those are gone. Those are gone. B minus 3 is that other factor. And what do we do with b minus 3 as that other factor? What do we always do when we have that large factor? We divide by the large factor. Like so. So finish up by dividing by the large factor b minus 3. There we have it being eliminated from the left hand side, and on the right hand side we are dividing by b minus 3. We may continue solving by analogy, maybe until the end of these tutorials we will not encounter any entirely new situation. Y is the proposed subject and we need to eliminate everything that is in its way. As usual, we will begin with the one that is least related to it. The square root operation is the culprit. Its opposite is square, as we have done on quite a few other occasions. This opposite of square is square root. The opposite of square root is square. And the square root is the one that is least related to the proposed subject. On this occasion, we will eliminate the square root first by doing the opposite of the square root, which is square. And we do that on both sides, like so. So, on the left hand side, the square root is eliminated, and on the right hand side we have the square. And we are saying, because this is a common mistake that students make, the square root is eliminated from the left hand side and the expression on the right hand side is squared. Remember, 3 squared is equal to 9. So some students will put 3b squared again, not squaring the 3. Everything has to be squared, including that 3. I realize that students generally do this. They do not square coefficients much, but you need to know that the coefficients should be square if the entire term and all has to be squared. In transposition, we usually eliminate the denominator first, but there is no reason why we cannot eliminate m, that is multiplied by y, by division, and t, that is the divisor, by multiplication at the same time. So there is no reason why we cannot eliminate this m and this t at the same time. So we will go straight ahead and do that by multiplying by the appropriate fraction. T is gone and m is gone. Just multiply by a fraction that will eliminate the t and one that eliminates the m also, and do the same on the other side, being then multiplied by t over m. We have the t is gone, the m is gone, and we have times t over m. Y is alone on that left hand side, and we write 9b squared t over m, and that is what y is equal to. Mathematics is for total mental development. Judgment and discretion are not to be left out. I always discourage students from making 2 steps in one. However, in this particular case, I think that it is fair judgment to make an exception, and I am doing that knowing that I am in no danger of making a mistake by so doing. Therefore, I have no hesitation about going straight ahead and eliminating those 2 rejects at the same time.